Let's create a skewed data. I'm creating a skewed data. Okay. One is so I ran this skewed data. You see now. So if you see this data is having uneven columns, we did partition spark partition ID we created, right? In partition ID, if you see, we have 3 partitions with uneven columns. So now we are adding salt column, and for the we are concatenating the order date with that salt column. And I'm repartitioning that, and I'm dropping the salted one. Now let's run this. I'm controlling the level of distribution, concatenate with partition to create a salted key. So repartition under salted key. Now salting technique. And we are introducing a random salt and repartitioning the data based on salted key. After we can perform the joins. Okay. So I'm adding again salt. So now if you see, right, before salting we have this partition, and after salting is this one. Total records are same. Forty 424 these records. This is data skew. So this is causing data skew. After salting, we actually reduced. We distributed that, right? Even though it is running more, like runtime increased here, uh, but the performance is increased here. Like if you see here, total records balanced better, slightly slower, faster. improved but not runtime because the data set is small. So that's why, because of in real time, it will reduce bottleneck and increase the speed. If you see here, before we had this is before salting. We have skewed data. Now I added salt column and created a salt order date. So that's the one. Now I am adding the partition ID to count. I'm repartitioning the salted key. So now it got distributed. So we already saw, right? This one. Before, after, smaller skewed data. Now it's much more balanced. Though the time got increased, but in real time it will work. Next, workspace. So before we used to have a single pass optimization approach. We have a thorough execution plan and it adhered to the plan. But now because of AQE, it has dynamic partition pruning optimize. It will choose either shuffle or broadcast based on size. It automatically detects queue data by splitting smaller partitions into smaller ones and process separately. Dynamic, it will switch execution plans, dynamic switching based on runtime statistics. It can automatically coalesce small partitions into larger one, reducing overhead. This is without AQE. Number of blocks, text execution summary. This is took 5-4 milliseconds. Rows output, tasks total, number of batches, these all. Okay. Now let's enable the AQE. Let's Click here, go to this one, click on this equal data frame, click on this, put on shuffle. Okay, we had a broadcast join. See, tasks only one. Number of output also reduced. Blocks, number of output batches compared to previous and this one. Let's go to text summary. See, it took only 266. Previously it took 5463. And it is using photon shuffle, all this. Now here it's using broadcast join also. So that's the difference. So we need to enable this. So this is AQE part. So before 3.2, before Spark 3.2, AQE, there was a salting technique we used like this, like I showed you right here, this one. We need to create a salt using floor rand, and then we can have to concat the salted key, and you have to repartition the salted key. After you repartition, we need to adjust the partition ID column group by to get total records. This is 3.2, I think. Yeah, before 3.2. After 3.2, adaptive query execution is there. We already saw how to enable that.